Okay, so this video right here is covering wave speed. Now we are in Unit 7, which covers waves and wave properties. This is, we've covered different types of waves, we've covered different properties of waves, and we are almost ready to have a test. Now this will be the last topic we will cover. If you notice, there's not been any math yet in this unit, because there's not, but like one or two types of problems, and that's what we're going to cover today. Now they're pretty easy problems, so we're not going to spend 2 or 3 days on them. We're going to, I'm going to go over some sample problems. We're going to do a worksheet, and I'll give you a few. And then we will, I'll give you a couple problems on study guide, and then we will have a test probably this Friday on these problems. They give us a day, Wednesday to do a study guide, and then Thursday to do a review, and then Friday to take the test. So we cover wave speed. We have an equation for that. Now, if you notice the properties of waves, wavelength and frequency are what's important when we're talking about wave speed. All right, so wave speed is, we use a V for that because that's velocity, speed, kind of the same thing. Wavelength is this like Greek letter lambda. All right, it's a symbol like this right here, and then F is frequency. Now, our wavelengths are going to be in meters. Our frequencies are in hertz. Right? Well, what a hertz is, it's actually a unit of 1/seconds. So these units of wavelength times frequency, the units end up being meters per second, which is for velocity anyway. But that's our equation. We'll just, rearrange it. We work problems like this all year long using these equations and using algebra. There's some things you need to know, and all this stuff will be on the test. If we have a symbol V, that stands for wave speed, and it is in meters per second, and the units meters per second. That, like we just said, that Greek letter lambda is the wavelength. It's in meters. The unit symbol is M. Frequency is F. It's measured in hertz, which the unit of hertz is actually a 1/second. And we use Hz as the symbol. And then we have something else called T, and it is for what's called the period. It's measured in seconds, and we use S. So we'll have to be doing that. So when we have frequency, the way we define that is the number of complete waves passing a point in a given time. So frequency is equal to the number of cycles, or the number of waves, divided by time. So how many waves go through, a certain amount of time. If 10 waves pass in 1 second, the frequency is 10 hertz. It would be 10 divided by 1. If 6 waves pass in 2 seconds, the frequency is 3 hertz, which would be 6 divided by 2. And of course, we have this thing called the period. And what we need to know about a period is that the units or symbol are seconds. So it's a measurement of time of waves, and it is the reciprocal of the frequency. So T is equal to 1 divided by your frequency. That's an equation we could use. Or if we're solving for frequency, that would be 1 divided by T. They are reciprocals of one another. That would be our equations. That's another equation to add to that top one that we'll be using. So there's a couple equations here. We have to look and see what the problem's asking us to see which ones to use. All right, so let me erase this. We'll work some sample problems. So sample problem A says a wave has a frequency of 50 hertz and a wavelength of 10 meters. What is the speed of the wave? So we know we work these using the guess method with our givens, our unknown, our equation, and then substitute and solve. So I'll write down, it tells me I have a frequency of 50 hertz, wavelength of 10 meters. What is the speed of the wave? Well, I know that it gives me that frequency is equal to 50 hertz, wavelength is equal to 10 meters, and then I want to know my speed, which is v. So I look at this, I decide the equation I'm going to use is this v equals f times wavelength, or the other way around, wavelength times frequency, it doesn't matter. Then I substitute and solve. So v is equal to, f was 50, and I multiply that by my wavelength, which is 10. When I multiply those together, my speed would be 500 meters per second. So it's a really simple equation to use. It's just like we did all year. And most of you know your grades are very good this year. You did a good job of learning this stuff without me being there. Now, sample problem 2 says a wave has a frequency of 5 hertz and a speed of 25 meters per second. What is the wavelength? So again, we'll write down my givens, my unknown. It tells me a frequency of 5 hertz. So F is 5. Speed, V is 25 meters per second. And it's asking me for wavelength, which is that lambda. So again, the only equation I can use is this new one we've come up with. The velocity equals frequency times wavelength, or the other way around, wavelength times frequency, it doesn't matter. I'm going to plug in my numbers. For velocity I had 25 equals my frequency is 5, and then I still have my wavelength here times wavelength. Divide both sides by 5, so my wavelength is actually equal to 5, and then it's going to be in meters. Now, one thing I need to make sure of is that my wavelength is always in meters. If it's not, I will need to convert and change it to meters. So you have to really pay attention, like this next problem. A sample problem 3. A wave has a wavelength of 1,000 centimeters and a speed of 340 meters per second. What is the frequency of the wave? So again, it tells me my wavelength is 1,000 centimeters. And then it has a speed of 300, so my velocity is 340 meters per second. What is the frequency? This 1,000 centimeters ain't going to work. I need it in meters. How do I go centimeters to meters? I divide by 100. If you divide 1,000 by 100, that would give you, 10 meters. So simply centimeters and meters, you divide by 100. So then my equation I'm going to use is V equals frequency times wavelength. Plug in, my velocity was 340. My frequency is my unknown, but my wavelength was 10. That's times my frequency. Divide both sides by 10 to get my frequency by itself. So frequency would be 340 divided by 10, which would give you 34. The units for frequency is hertz. So it's pretty simple problems using that simple equation right there. Now, next sample problem we have, look up here at the top. Playing middle C on a piano produces a sound with a frequency of 250 hertz. So it's giving me a frequency. What is the period of the wave? Now, the period, the equation for period, we're only given frequency here. And we're asked to solve for the period. That's our unknown. Well, our equation that relates those two together is T equals 1 over F. If I was given the period and asked for the frequency, I would have used F equals 1 over T. But I use this form of it. I plug in my number, so T is going to be equal to 1 divided by 256. I get my calculator. One divided by 256 equals 0.0039. So it'll be 0.0039. The units for periods is the second. So I just put an S there. Remember the units. I'll ask you all this on test. So that's the other equation. We just talked about two of them. Pretty simple. Now this is one more type of problem in this though. If we look at sample problem 5. If 9.5 waves break on a beach in 1 minute, what is the frequency? One other equation that we had, and if we notice we're given waves. We're given waves, a wave number, which is 9.5. We're given a beach, we're given a time of 1.0 minutes. How do I change 1.0 minutes to seconds? I will just multiply it by 60. So that would give me 60 seconds. Now, my equation for waves, I did have one other. If you read your notes, it says the frequency is equal to the number of waves divided by time. So I would just plug that in. Frequency is going to equal to the number of waves I have was 9.5. The time in seconds was 60. So if I take 9.5 and divide it by 60, I get to 2 decimal places 0.16. So that would be 0.16. The frequency is measured in hertz. Now, those are pretty simple problems to do right there. So these are practice problems for you to work. Now, make sure that all your wavelengths are in meters. If they're not, you want to change them to, if they're in centimeters, you want to change them to meters by dividing by 100. Now, if you look at, see one sample problem. All right, if we look at number 11, I just want to go over this one. Water wave has a wavelength of 5 meters and a speed. It's a wavelength of 5 meters and a speed of 2.5 meters per second. Just want to know the period of the wave. Well, we know for period that is T equals 1 over F. So we need to know our frequency. So first in this problem, solve for frequency. And you do that by using, V equals F times wavelength. So you're going to solve for frequency and then solve for your period or your T by using T equals 1 over F. So that's just like a two-step problem right there. Again, make sure every time you see something in minutes, change that to seconds. So there's basically, if we review back over what we talked about, we have a few equations. We have for wave speed, we have V equals frequency times wavelength, while they're beside one another. We also have, frequency would equal the number of waves over the time interval in seconds to find frequency. If it gives you number of if it gives you, we can also solve for the period, which is T, with 1 over F. And period is, the units are seconds. Or we can use a reciprocal of that, F equals 1 over T, to solve for the frequency if we were given period. That's how you do those problems. We're not going to spend a whole lot of time on those because they're pretty simple. Like I said, I'll give you some more on the study guide on Wednesday. And then we'll have a test on this whole unit on Friday.